An electron at rest has a charge of that amount. It start moving with velocity v equal to c by 2, where c the speed of light, the new charge. Actually, we know that charge is invariant with speed. It means charge on a body does not depends on its speed, whether it is at rest or it is moving. The charge on the body is the same, while mass changes. If suppose there is a body of mass m naught when it is rest, but when it is moving and its speed is not very small, but compared to with the speed of light, its mass m is slightly increased as compared to the mass at rest, and its value is governed by the equation. But this is not the case with the charge. Charge on a body. If this body has charge q, it will still have the same charge q. So charge does not change with the speed. So if the body have charge, electron have a charge this much, even at that speed its charge will be the same as before. So A is the answer. Now there's a question. Correct test for electrification is, definitely it is repulsion. Let me explain you that suppose I have a uncharged body. This is uncharged, and I have a charged body. I don't know this body is uncharged, but I have this body which is positively charged. By electrostatic induction, it acquires negative charge to this end and positive charge to this end, and due this charge being closer to this, so the attractive force on this negative charge by this positive charge will be greater as compared to the repulsive force on this positive charge. So net force on this uncharged body is toward this positive charge. It is being attracted even though it is uncharged. So there is an electric force on it even though it is uncharged. So attraction is not sure test for electrification. But if a body is positively charged, if a body is this body is charged and another body I have here, and if this is repulsion, this body must be a charged body. So repulsion is sure test for electrification. If a body is being repelled by somebody else, this must have a charge. There is a question. A force of 12 newtons is acting between charges of 2 microcoulomb and 6 microcoulomb. If both charges are increased by minus 2 microcoulomb, what is the force? Actually, force between 2-point charge is proportional to product of the charges. Here the product is product of 2 and 6 is 12, and the 12 Newton force is also acting between. Then if this product is 12, now if we add minus 2, so we have plus 2 microcoulomb, and we had plus 6 microcoulomb. Now minus 2 microcoulomb is added to this one, and minus 2 microcoulomb added to both bodies, so this become a 0 and this become 4 microcoulomb. So their product will be 0. So as electric force is directly proportional product of the charges, the product being here is 0, so force between them will be 0 as well. The dielectric constant of pure water is 81, the absolute permittivity. So we know that absolute permittivity is this one. Absolute conductivity of a medium. Now K is where K is dielectric constant. Dielectric constant, which is 81 here, 81 into, and this is 8.85 into 10 to the power minus 12. So this come out to be almost 7.18 10 to the power minus 10. So this is the answer. A soap bubble is given a negative charge, its radius. Suppose this is a soap bubble. See, this is a soap bubble which when become a positive charge is given, and it will reside over its surface. So due to their repulsive force, I mean, suppose this is positive, this is positive, so there will be a repulsion, mutual repulsion between the charges. So this wants to this bubble wants to increase radius, I mean the new radius will be a bigger compared to the initial. So we can say this bubble will enlarge, so its radius will increase. So this is the correct one answer, due to repulsion it is actually. Now here the question is, we have a 2-point charge here. We have 2-point charge, 1 microcoulomb and 5 microcoulomb. What is the ratio of force on this? I mean we have two charges. Yeah, I may assume that the charge on them are different, as here 1 microcoulomb and 5 microcoulomb. We know the force between them depends upon their product, I mean it proportional to product of the charges, but by Newton's third law, Newton's third law, I mean of action and reaction, if this charge exert certain force on this, same amount of force will act equal and opposite. I mean the magnitude of this force is same as the magnitude of this force, only the direction are different. So the ratio of these forces are 1:1. I mean this is the correct answer. In this question, total charge Q is broken into two parts, Q1 and Q2, such that, and they are placed at a certain distance r from each other. The maximum force of repulsion between them will occur when. Hence the question is actually I have to break this charge into two charges, Q1 and Q2, in such a way that their the force, the maximum force occur between them. So the product, the electric force between these two charges is directly proportional to product of the charges. So for this to be maximum, this product must be also attain maximum value. So let assume this charge is x, so this will be q minus x. So we can write the force between them is k x q minus x upon r square. So we know f is a function of x, I mean the force depend upon x. So changing x, we will change this force. So we have to find what should be the value of x such that this f be maximum. We know at the value of x where this force is maximum, at this point the slope will be 0, I mean df by dx will be 0. So I have to differentiate this and equate to 0. So k by r square x q minus x square to be 0. So q into 1 minus 2x to be 0. This implies x equal to q by 2. So one part, this comes out to be q by 2. So rest part will be q minus q by 2, also will be q by 2. So the correct answer is D, q1 q by 2 q2 q by 2. So this is the answer.